Good afternoon. This is Chuck Doty with UNEX Manufacturing. I want to thank you for joining this discussion on order picking in a distribution or fulfillment warehouse that's not automated. Seems like my PowerPoint is not working. Okay, this should look to everyone like a storage warehouse system where we have the full reserve storage in the overhead position, and the bottom level is case picking. So if we treat this as the baseline of an order picking warehouse, we want to try to make improvements on this picking from a pallet system. So let's use the 3 S's and apply it to each type of picking storage system: speed, space, and safety. So back to the baseline picking off of a pallet system.
Please enter your access code followed by the pound or hash sign.
Let's first, somebody's
To enable audio control, please enter your audio pin followed by the pound or hash sign.
let's first apply safety to this pick position. So you can see that the order picker has to bend over to reach to get to the box. So from a safety standpoint, that is the worst ergonomic pick: bending over and lifting, reaching with your arms extended. That's what you don't want to do. From a space standpoint, this position had to have the second level beam raised to give the operator clearance to reach in to get the box. So we're losing some space here. From a speed standpoint, it's relatively fast. He has access to most of the boxes easily. And since this has a large volume of boxes, a complete pallet load, he can pick many boxes readily. But the speed is challenged when you get to the bottom of the pallet and you have to step into the bay to reach and pick the box. So that loses speed. But from a standpoint of fast-moving products, this is the most common pick, because once you pick this pallet complete, then you can just bring down another pallet out of reserve storage and put in its place. So for fast-moving items, this is the best pick and the highest used pick. So if the warehouse is starting to run out of space, maybe the next logical step is we're going to go vertical and use a man-on-board forklift to pick cases off the upper levels. So from a safety standpoint, this has a lot of the same characteristics as picking off a pallet. At some point, you're going to be bending and reaching and lifting. So that can be a negative. From a space standpoint, we can utilize a lot of space this way. So this is good for space utilization because we can just go vertical. But from a speed standpoint, this has a lot of negatives. The vertical travel of the forklift is not very fast. When the forklift is in the upper position, the horizontal travel back and forth is greatly reduced, so you cannot move that forklift very fast. So for very slow moving products, this could be a good alternative. So maybe the next step would be, let's take product off of the pallet and hand stack it onto static storage. So this could be shelving or it could be wire deck. And just hand stacking onto these levels creates more SKU positions. So instead of having 2 pallets in a bay side by side, now we could have maybe 15 or 20 positions per bay in 3 or 4 levels. But again, the access, the safety access to get to the product, you're still going to be bending and reaching, so that has a negative aspect to it. The speed, the products are accessible, and also you've condensed the travel to get to the product. So from a speed standpoint, this has increased the travel between SKUs. So now let's apply dynamic storage as the next operation. Carton flow will increase more positions. You'll get a higher density of SKUs. And you can create a moderate amount of volume with all the boxes stored behind each other. So with the carton flow, you might get up to 30 SKUs in a bay in 4 or 5 levels. Then for the fastest moving items, you can use pallet flow, which will double the available storage. So for your very fastest moving products, pallet flow is a good option. Again, you have the same reach and bend characteristics as picking from a pallet, because you're basically picking from a pallet. So carton flow would be for the slower, medium to fast moving products, and pallet flow would be for your extreme fast moving products. So the basic principle of how you want to apply these storage systems is you want to match the storage to the amount of order picking going on. Match the storage to the movement. So here's a test of space and movement. And what we're showing here are 2 lanes of carton flow. The lane on the right, we're picking full cases. The lane on the left, we're picking eaches out of the case. And each case has 25 inserts in it. So you can get information from operations in the warehouse that say, well, my pick rate is 4 per day. But that doesn't really tell you the story of what you need to know. So if we were trying to design a system that had between 1 and 2 weeks of inventory before we had to replenish that carton flow line, which one of these would be the correct use of carton flow? And this is a rhetorical question. The answer is neither would be the correct one. The full case pick on the right has 5 cases, so you'd almost be restocking every day. So you might as well pick off of the full pallet for that position. The boxes on the left, the carton flow lane on the left, has over 2 months worth of inventory, which is not going to turn over nearly fast enough. So you'd probably put that on a static storage system. So it's the pick rate plus the cubic space is really the equation. How fast you're picking each item and how much space it's going to take up. So an average distribution center is just a big container. It's just putting a lot of SKUs and storing them inside the distribution center. But all of those SKUs that we are storing do not go out the door quickly. So Perritos Law states that 80% of all your SKUs are slow to medium moving products. Or you could say that in the reverse way, 20% of the items in the warehouse represent 80% of the volume that goes out of the warehouse. So these medium to slower movers are where you can really pick up a lot of advantages in how you lay out the warehouse. It's easier to identify the fast movers, but tailoring the warehouse to make the medium and slow movers work well is key. So there's really only two types of less than pallet load order picking. You're either picking the full case or you're picking eaches out of a case, piece picking. So from a full case pick standpoint, all of these apply to a non-automated warehouse. The most common is you're just going to pick cases off of a pallet. The next level may be shelving or static storage where you're using wire decks in a pallet rack. Then you could apply carton flow for the medium to medium fast movers, and even pallet flow for the very fast movers. So within this system, you could say that picking off of a pallet or picking off of pallet flow might be 2 SKUs per bay. We're picking off of shelving or picking off of wire decks could be 15 to 20 SKUs per bay. And picking off a carton flow could be 30 SKUs per bay. So that kind of gives you an idea of what the density per bay could be. But all of these resources, all of these types of storage systems for picking can result in other net gains. So this image represents a row of pallet rack. So if I had this row of pallet rack, which is 16 bays long, and if each bay had 2 pallet positions in it, I'd have 32 SKUs and 132 feet of travel. So if you analyze a storage system and first look at the slowest moving items and say, I'm going to take the slowest moving products and move them part of the pallet, off the pallet onto, in this case, carton flow, and analyzed all of those slow moving items to move them to carton flow, I could condense that complete 132 foot row of picking from pallet into 1 bay of carton flow. So we've just eliminated 132 feet of travel. One order picker can walk up to 1 bay and have access to those 32 SKUs. So that is the speed. That's saving travel time, increasing pick speed. But the other gain that really pays for this operation is I've just opened up 15 bays for my fast moving products. So a warehouse is running out of space, here's a good opportunity to condense that space, make the pick travel much more efficient, and open up many more pick positions for fast moving items. So that is really, for full case picking, that is the key. That's what pays for the system. So now if we look at the next system of open box or piece picking, we could say that the first, it may not be the most common, but it could be the first system that someone would use would be static storage shelving, where you open up the box and you just stack them on static storage. But because you're picking out of the box, you got to leave enough room to extract the item out. So you're probably only going to get 3 levels instead of 4 levels in this case. Or you could slide the box out, pick the item, and slide the box back in again, which sounds like not a difficult or time-consuming item. But if you're picking thousands and thousands of orders each day, every small amount of lost movement adds up to be a big number over a period of time. So if we want to take this open box picking operation and apply the 3 S's to it, let's go to the next level. That would increase our efficiency. So we could take the static storage and just tilt it forward. We still have static storage, but because we've tilted the box forward, we have ergonomic access. It's a better pick to get in and out of the box. And at the same time, because we have access to the box outside of the storage system, we can condense our levels down. So now we could get 4 levels of storage instead of 3 and have access to those open box picks. The next system that could be utilized is a movable bin system. And this is where you actually decase the box. You take all the products out of the box and put it into these bins. These bins can move back and forth, so you have access to multiple rows of bins going into the bin. So where the previous we may have had, if it was a complete bay with 3 levels, we may have had 20 SKUs. With 4 levels, maybe 30 SKUs. With this movable bin system, you can have over 100 SKUs in a bay. But it's limited in the amount of storage for each bin. So again, you're trying to match the movement to the storage. So this would be for very slow moving or very small items. But if we had fast moving each picking, carton flow is the fast moving alternative. So here we've taken a tilted tray and attached a carton flow system leading up to it. So you get the advantages of the tilted tray to condense the levels on top of each other. And you've created a queue of storage behind the pick position. The picture on the left shows wine cases that are about 12 cases deep. So you can create a pretty sizable amount of storage within a carton flow system for each picking. And that would be the best alternative for picking the very fast movers. So just to recount here is the speed that we're trying to pick the orders. We want to try to reduce travel, reduce the number of restocking trips. So that's matching the correct amount of storage to the movement of the product, and making the product easily accessible so that it's safe. You don't get repetitive motion injuries. And the space, we always want to condense the space as much as possible within the storage space and within the pick location space. And again, make the pick as safe as possible. So match the storage to the movement is really the key to a non-automated distribution or fulfillment storage system. Thank you very much. If you have any questions or want some more information, you can email me at chuck@unex.com. Thank you.